Welcome and hello. This is a exercise video in HEC RAS, and in this video I'm going to be talking about adding a bridge as well as a weir or culvert in inline structure to a 2D flow area. Right? So typically on these exercises I'll start from scratch, but this exercise I'm going to actually continue on from the previous exercise, 32. That one's titled 2D flow area in a river. You can probably find it in the playlist. What I have on the screen here is the geometric data editor. What I have is a 2D flow area, an upstream boundary condition, a downstream boundary condition. And if we go over to RAS Mapper, we can go ahead and check out those results. I'm going to back out a little bit. What you're seeing here is the depth results. I can go ahead and click on those results. And then I can play through the simulation here just by pressing the play button, watching the depth increase and then decrease and so on with respect to the stage hydrograph that I defined in the upstream boundary condition. All right, so what we're going to be doing in this exercise is to add a bridge and also add an inline structure. And then what we're going to do is rerun the simulation, check out the results. To do that in a 2D flow area, which is what I'm using it from RAS Mapper, I'm going to go ahead and click on my geometry, this base geometry, click on the edit pencil, and you may be tempted to click on bridge, culvert, or inline structure, but what I'm actually going to click on is SA2D connection right here, and then make sure I'm in edit mode, and we're going to sketch a bridge from right here all the way crossing the river to over here, or right here. So I'm going to go ahead and zoom in and just do a single left click to begin, and then click, single left clicks. Let me pan over. I'm going to turn off the depth. Just continue clicking, and it connects right about here. Zoom in a little bit more, boom, and then a double click to stop. All right, so what I'm going to do is I'll call this train bridge. This is going to be the first of two bridges, or two structures crossing the river. The width of 100 is probably too much. Let me go to the actual map here. So here are the train tracks. I'm zoomed in a little bit too far. I'm going to click on the measure tool. This is Google Earth, by the way. This is the Yuba River, just outside of Marysville. All right, so let's see. What am I trying to sketch here? The width of this bridge is 20 feet. We'll just say 20 feet. So we'll say that the length of the pier is 20 feet. And then the width of the pier, kind of hard to tell. I mean, what we're seeing here appears to be the width of the platform. So maybe we'll just say 10 feet, 12 feet. All right, need to remember those numbers. So the width here, I'll just go ahead and say is 20 feet. Structure type, this is where I need to select bridge. And then I can add a description right down here if I want. I'll just go ahead and leave that there to make sure it copies over. And I'll go ahead and click OK. I'm going to go ahead and click stop. And then do I want to save the edits? Yes. And there's not a whole lot more I can do for editing a bridge here in RAS Mapper. Let's go ahead and check that out in the geometric data editor. I'm going to click on edit geometric data. All right. So it looks like we have our bridge that's been sketched in right here. Something else that this view reminds me I need to do is modify the cells. So underneath the bridge, I want to add more computation points so that it's the same density as in the main channel. All right, so I'm going to go back to my RAS Mapper window right here. Now would be a good time to toggle off the terrain and toggle on the 2D flow areas, which are right here. Yeah. Now I want to edit that SA/2D connections layer. Click Start Editing. Click on the edit. Now I'm going to select, right click, and then Edit 2D Connection is the one I think I want. Oops, no, it's not. Let me go right click, Edit 2D Connection Break Line Points. That's the one I want. And then this distance is going to be 50 feet. For near spacing, I'm going to say one level, or I should say one additional level. So that means we should have 50-foot spacing on both sides for two layers. So if I click OK, and then I need to click Enforce, which is this button here. All right, that looks good for the bridge, but it kind of messed up my main channel. I want the main channel to maintain this same spacing, which I believe was 50 feet. So that's not a problem. I'll click on this 2D flow area now, and then the main channel is a refinement region. So I just right click and then enforce all regions. Is that it? Okay, so that looks good. We need to add a computation point right here. Then I think we'll be on our way. Let's go add, clickety click, and looks good. All right. So I'm going to go ahead and stop the edits, save. This area may actually be a candidate for some manual editing. I just don't like how the the spacing is. So 1 second, let me go back, add a few more points here, here, and then maybe here, 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 and here, and here, and here, and here. Okay. All right, that looks a little bit better. So, and again, save that. Now let's go back to the geometric data editor, edit geometric data. You need to save your edits in RAS Mapper before geometric data editor will let you make edits. Oh, looks like we have a problem here once again. Okay, I'm in RAS Mapper. I need to go ahead and fix this one right here. So just add a few more points. All right, I think we're in the clear now. So let's stop editing, save the edits, go back to the geometric data editor. Here is my bridge. All right, let's go ahead and edit the bridge. So I'm going to click not on bridge/culvert, which may be your initial response. This would be for 1D flow, bridges and culverts. We want to click on this SA/2D connection. And then our only connection here is called train bridge. This is the one we want. And then here's my description. That's great. The connection looks correct. It's just upstream and downstream is the same 2D flow area called 2D flow area. And what I want to add here is bridge deckway, and then after that, a pier. So the bridge deckway, let's go ahead and just say it is a top chord of 80 and a bottom chord of 75, and it goes all the way over to the end here at 2,500 or 3,000. So that's pretty straightforward. The width right here of 20 feet carried over, so that's good to see. Now the distance from the upstream face of the bridge to the first cross section is the distance I'm expected to type in here. I'll go ahead and type in 30 feet. And then for the station, I'll go 0, high chord 80, low chord, what I say, 75. And then I'll just take this all the way over to station 3000. It's probably too much, but it's better to be too far than too short. All right, so I'll copy those values to the downstream end, and then let's go with a 3-to-1 slope for the embankment on both upstream and downstream, and click OK. All right, so there in the diagram is our deck roadway for the bridge. Now what I want to do is add this is the piers button right here. So I'll go ahead and get started. This is the upstream and downstream stationing fields. Let's go ahead and add a pier every 500 feet of stationing. So starting with 500 upstream and downstream. And then for the pier width, I think I said 12 feet when we were looking at the Google imagery. The elevation will start at, we'll just use a sufficiently small elevation that will be correct, sufficiently small for all the piers along the length of the bridge. So if the water is, say, 35, I'll just go ahead and say 20 here for the low elevation, and then I'll go up to 75, which is the elevation of the low chord. So I'll just go ahead and repeat that for downstream. 12 is the width from 20 up to 77. Okay, I'll say there's no debris, just leave that blank, and then click OK. All right, so there's my pier. It appeared right there at the 500 cross-section station, which is the length along the bridge. To make a copy of this pier that's really quick and easy, I'll just go to pier. I have pier 1 selected. It's the only pier there is. It automatically starts you with one pier when you open this editor if you don't already have one. And then click on copy. Now, the only thing I really need to do here, because I've set it up properly, is just change the station. I'm going to add 500. This is now station 1000. Click OK. All right, there's that. And I guess I need to just keep doing this. So let's go ahead and make a copy. Now this is going to be 1500. So there's that. And then copy again. Okay. And this is the fifth and final pier at River Station 2500. So if I click OK, the rest of the piers now appear in place in this cross-section view. So that's exactly what I'm looking for. This view in this profile that we're looking at here is inside bridge on the upstream side. I actually have 5 different views that I could be looking at. For instance, the upstream bounding cross-section has a similar, but not exactly the same cross-section. And then if I go to the center of the bridge, we see the center of the bridge. And then there's also downstream inside bridge and downstream bounding cross-sections. I'm going to just put it back to where it started, the upstream inside bridge. And what these 5 different plots, they're called, refer to are, I need to zoom in to explain it. We should see 5 separate lines here, red dotted lines. So 1, 2, 3, 4, and 5. Actually, let me zoom in a little further. In fact, let me turn off the symbology, or modify it at least. So edit lines and symbols. This light blue for the 2D flow area just feels a little bit too much for me sometimes. So, okay. Okay, so I have the terrain layer on. Let me toggle that off as well. And then we can toggle that back on if we want to. All right, so here's the downstream most line, second, third, fourth, and fifth. So this distance here is that 30 feet I typed in, and then we have the width of the bridge itself, which was 15 feet. So 7.5, 7.5, and then another 30. So let's go ahead and see how the bridge behaves after we run the simulation. I think we're all ready to go. So I'm going to go ahead and save this geometry data. If you're curious and didn't want to review the previous lesson, the upstream boundary condition is controlled by a stage hydrograph, which ramps up from 45 feet of stage up to 60 feet, and then back down to 45 feet, and then holds constant. The total duration of the simulation is 3 days, so 72 hours. All right, let's go ahead and click OK, and then run the simulation. I'm going to click on the running man stick figure here, and I think everything here is good to go. I'll click compute. Oops, we got a problem here. Okay, I remembered what I needed to do to get that problem fixed. And there's a couple things actually. The first is I need to open up my train bridge editor once again. HTab param. We need to click on this HTab param and then fill out this field, and it's recommended the last field too. So headwater maximum elevation. I'm going to go ahead and just say 80. Let's go ahead and say 90. That'll be 10 feet above the high chord. So that's plenty high. By the way, I redrew the bridge off camera. It's similar, not exactly, but close enough. And then for the maximum flow, I'll just go ahead and say something ridiculously large, like 100,000, and then it's good there. Okay, let's go ahead and see if that runs. So let's close this, go File, save the geometry data, and then compute. Okay, so it's telling us that Manning's N values need to be added for the upstream and downstream cross sections, and that's for that train bridge. That is located in, let me open up the editor again. It's under options and then internal and external bridge cross section data. It's looking for a Manning's N value. So these are the 4 cross sections here. I'm just going to keep it simple and say one single cross section will define the Manning's N for all stations. So I'll just say something like 0.05. So if you only have one value, just type it in the top row, and then that will assume to be copied over for all the lower rows. Okay, if you wanted to change it, you can do that in any of the rows. And let's go ahead and see if that runs. Oh, and also one more thing, I need to also set the contraction expansion coefficient for the bridge. And it looks like it's default of 1. Okay, that's cool. I'm going to say 0.5 on the entrance. Let's go ahead and file, save the geometry, and then our unsteady flow analysis and compute. Okay, the storage connection editor contains data that has not yet been applied. Do you want to apply this data to the analysis? Yes, not sure what that is, but looks like we're up and running here. All right, that looks successful. Great. Let's go ahead and check out some results now. So I'm going to close this, close, close. Let's go to RAS Mapper, which is this button right here. Oh, I already have it open apparently. Okay, there's RAS Mapper. All right, so I'm going to toggle on the depth. I'll toggle on all 3 of these results, depth, velocity, and water surface elevation. Let me make the screen a little bit wider here and then just dial back the slider bar. Okay, so I'm starting the simulation now. The water should be increasing, the depth. So here is our bridge. I'm going to go ahead and back it up to, how about the very beginning? And then I'm going to turn on the part, how about the arrows first? So this shows the velocity vector of the flow. I'm going to go ahead and press the play bar a little bit. Okay, so now we have a higher flow. Now I'm going to turn those arrows on again. Oops, that's particle tracing. We'll check that out too. So here are the arrows. I actually like the white arrows a little bit better. Black to white. Okay. I can see the white on the dark blue a little easier is all. I'm going to push it forward a little bit more and turn off the arrows, turn the arrows back on. Since we have larger, longer arrows over here, that means the velocity is faster, which makes sense because I believe the depth of the channel is also deeper over here. Let's go ahead and toggle off those flow arrows, but toggle on the particle tracing. So yeah, that definitely confirms it for me. The particle tracing here shows that we have much more flow and higher velocities over in this part of the channel as opposed to over here. All right, let's go ahead and sketch out that cross section and check out that velocity gradient. So I'm going to turn off the particle tracing, and then I'm going to scroll up and add another profile line just along this bridge here because this is an interesting location. I'm going to start sort of back here and just go all the way across, double click. Okay, profile line 3, that's fine. Now I want to go ahead and check out the data here. So right click and then plot profile and then velocity right here. Okay, so this is pretty satisfying. What we have here is the velocity is like 11 feet per second or something, way out at river station, or sorry, cross section station 1100 or 1065 is about the maximum. So we have very low flow, maybe 2 or 3 feet per second, all the way from what cross section station 220 all the way up to almost 1,000, and then it really peaks here. And that's why we were seeing those larger arrows and faster particle tracing lines in the previous two views. All right, well, enough results here for the bridge. Let's go ahead and add an inline structure. I'm going to go ahead and just navigate further upstream. How about right here? So to add an inline structure, it's a similar process. We're going to start by creating a 2D, SA2D connection again over here in the geometry file in RAS Mapper. That's right here, SA2D connection, and then start editing. And then I want to click on the add new feature. Okay. I'm going to go ahead and zoom in, and I'm sort of arbitrary about this. I'm just going to click right here and then straight across right here. Name, I'm going to call this car bridge. The width, 20 feet. Let's go ahead and make it a little bit wider. How about 40 feet? And then for structure type, we're going to just leave it as it is. Weir, gates, culverts, and outlet. The previous example with the bridge, we selected bridge, but we could also change this later in the geometric data editor. Okay, I'm going to go ahead and click OK. Now what I want to do is add a culvert. So I'm going to come down here to culvert and then add. And now I'm going to zoom in a little bit. It looks like this is the deeper part of the channel. So I think this is probably a better place to add the culvert. I'm going to toggle off the depth results. Actually, all the results are kind of in the way. Yeah, you can definitely tell from the terrain data that this is the deeper part. All right, so I'm just going to go ahead down here, do a single click and then a double click. What I just added was a culvert. The invert elevation here is 38. I believe that's what the terrain is registering at. I'm going to go ahead and put it at 40 and have a downstream of 39.5. So it's not exactly at the invert, it's about a foot or so up. And then the length is 60 feet. Let's start 59. I'm going to just make it 60 so it's a round number. And then the width is 10 feet. The problem with this view, it doesn't tell you how high the culvert is. It just tells you how wide and then the length and the invert values. So we're going to go ahead and add a couple more culverts and then head over to the geometric data editor, make some final edits that we kind of need to, such as Manning's N and then the shape and a few other things. Okay, so I'm going to click OK. Okay, so I wanted to add a few more. I'm sorry. I'm going to click on edit, highlight that culvert, right click, edit barrel, and then this barrel's the one and only barrel. I'll just call that B1 for barrel one or culvert one within my culvert group. What I'd like to do is make a copy of this one culvert barrel by clicking on the copy tool. Okay, so let's add maybe 3 more and then click OK. Okay, so they came in right there. Actually, let me cancel that and add 6 more. So let's change that to a 6. Okay. Yeah, that looks like there's space for it. 15 feet of spacing. It's 10 feet width, so that'll work. I'll click OK, and that looks good. Let's go ahead and click Apply, click OK, save these changes, and then go over to the geometric data editor where I feel like I have a little bit more control over the editing. Yeah, it says there's some sort of error here. All right, I got the geometric data editor up on the screen here, and it looks like I need to go back to RAS Mapper to enforce the center line and the cell boundaries. I want to keep that 50-foot cell spacing. So we have the same issue with the bridge. Not a problem though. I'm going to go up to GIS Tools, RAS Mapper. I click on the geometry, click on Edit, 2D, SA2D connections. I want to select this right here, and then I want to go right click, Edit 2D connection breakpoint properties. Okay, so just as before, I'm going to use 50 foot and then 1, so both bridges use the same data. Okay, and then enforce. All right, so that looks good there. I'm going to save the edits or stop the editing. By the way, the culverts disappeared. I had some sort of saving problem, so I've sort of given up adding and editing the culverts here in RAS Mapper. Let's go back to the geometric data editor. Yeah, and I've been getting this error also, but it hasn't stopped me from going to the geometric data editor. Okay, anyway, this looks like it's updated. I'm also going to turn off the symbology. This light blue just seems to be a little overwhelming for me. All right, so that's a little easier on the eyes. I'm going to click on SA2D connections. What is this? Okay, so I need to fix this geometry here. Let's go ahead and just say that the invert is, or sorry, the top elevation is 70. because I think I'm not sure what I'm looking at here. Let me click on, yeah, so this all needs to go. Not sure if that was supposed to be the existing ground or what, but let me move that over there. And then I'll just say station 0 to station, what is this, 572.8. So I'll go 572.8. Okay, so the elevation will be 70 and 70. I'm just going to go ahead and click OK to see if that looks all right. Okay, right. So that was just the existing ground elevation. I'm going to put my culverts in right here. So let's do that. I'm going to click on culvert. The type of culvert is going to be, let's go ahead and start a new group. Culvert group 3, apparently. I'm going to rename this and just call this all culverts is the name of the group. Okay. Circular. Now let's go ahead and make it a box. And then the span I'll say is 10 feet. The rise we'll say is also 10 feet. The length we said was 60 feet. I'll just go ahead and make up an entrance loss coefficient, Manning's N, something typical. 0 is fine there. And then what do we say for the invert? I think it was 40 on the upstream side, 39.5 on the downstream side. And then for the number of barrels, with 15-foot spacing, maybe I'll start it at 105. And then the downstream station will also be 105. So if it's, I'll say 120 will be 15 over, and then 135. All right, so I got barrels 1 through 5 here. They're spaced 15 foot apart on center. I think that's all. I'm good here, so I'll click OK. All right, great. So there are my culverts. And just to add something else, I'm going to add a notch in the top of the weir here, so it's sort of like a spillway of sorts. Weir embankment. And let's see, let's go from 70, how about down to 60 for 100 feet, maybe from 100 to 200 on the station. So I'll click on this row. I'm going to insert 2, 3, 4 rows, say 100, and then twice, and then 200. So let's go ahead and say 70, and then 70, and then, well, the invert there would, for the overflow would be 60. All right. So if I click OK, I now have my little notch right here. So as the water increases, it's obviously going to spill through the culverts first. And if the water level increases more, then it'll spill through this notch in the weir. And then after that, it would just overflow. I think that's good. Let's go ahead and see what happens. So I'm going to go up to the run and then unsteady flow. And then let's go ahead and click compute. All right, looks like it's working. All right, so it's done. That looks successful. No error messages, not even a warning. Let's go over to RAS Mapper and check out those results. So what I have now on is the terrain, and that's fine. I want to toggle on, let's toggle off that 2D flow area. All right, and then let's turn on the depth layer right here. All right, and let's go ahead and run the simulation. So I'm going to click the play button. The water is going to start to increase. Yeah, you can see it's definitely backing up upstream of this inline structure that we added. So that was pretty awesome. Let's go ahead and check out the velocity. So I'm going to go ahead and roll it back to, say, the very beginning. Pause it. Let's take a look at the arrows. Okay, bigger arrow through the invert or through the culvert. And then let's turn that off. Let's turn on the particle tracing. Okay. Let's go ahead and turn that off. And I'm going to go ahead and advance the simulation to high water mark, which is right about here. Now let's turn those flow arrows on once again. Again, I want to make them white. So boom. All right, that looks better. And then if I turn that on and turn off and turn the particle tracing off, yeah, you can see it's feels like it's slow and kind of getting backed up. And to turn that off, turn the arrows off. Let's go ahead and do one more thing. Let's modify that flow file. So we'll set a higher peak so that we get more flooding and more than what we got going on right now. I'm going to go up to the unsteady flow data editor here. The stage hydrograph, I could create a new stage hydrograph and a new unsteady flow data file. I'm just going to go ahead and modify the existing one. So we'll start at 45. That's a stage. And then we'll go up to not 60, but let's go up to, say, about 75 feet. So I'll type in 75 there. I'm going to delete all the values between those two. And then same with 75 down to 45. Say here, delete, and then interpolate, and then click on the plot. All right, so we have a much higher stage at that upstream boundary condition. All right, so click OK. I'm going to go File, save the unsteady flow data. OK. And now I need to run the simulation one more time. So let's do that now. Compute. So that finished up. That looks good. I'm going to go ahead and click Close. And then let's take a look at those results in RAS Mapper. So I'm zoomed out quite a bit. So we have our upstream car bridge, our downstream train bridge over here. Let's go ahead and click play. And here's the depth increasing. All right. Very nice. All right, so that's it. All right, well, that's it for this exercise. What we did is started with an existing model, and then within this 2D flow area, we added in a bridge right here, a train bridge, and then we added in a car bridge further up, defined the properties, ran the simulation, and then viewed the results.